Hello everyone, in today's session we're going to have a general review of Tekbox TBMR-110M. A EMI receiver works from DC all the way to 110 MHz, together with many other useful and interesting features. Because of its diverse features, we're not going to cover everything in a short video. So this one really is a quick walkthrough of its capability, okay? So first, let's have a look at the product form factor. You can see, compared with my laptop, which sits on top of it, this is really the product itself. Okay, it has an on-off hard switch, a USB link connection connected to my laptop, which runs the software control. Okay, has a small screen, and this screen can show the same graph like that or communication message. Okay. But most of the time, you would probably use the software rather than using this very small screen. Here you have 4 LED lights telling you connected, measuring, tracking generator output, and if you are measuring something very noisy, it can gives you an overload warning light as well. Okay, has a tracking generator embedded. Okay, so this would be useful if you're doing something like insertion loss of a filter. You can use the tracking generator function. Has an RF input, okay? And currently, as you can see, it's terminated with a 50 ohm impedance, okay? So yeah, that's really the front end of the product. As I said, most of the features are controlled by the software, currently run on Windows platform. So let's have a deep dive on the software features now. If I double click the software, it brings me this interface. As you can see, this really lists the key features of the receiver. It's a receiver, okay, but in the same time, it works as a spectral analyzer, has a tracking generator function there, and also, most interesting, it can also work as an oscilloscope. I have to mention that this oscilloscope is not really your normal type oscilloscope, because if you look at the interface, it only has a 50 ohm input impedance, while your normal oscilloscope has a 1 mega ohm input impedance, right? That works with the 10:1 passive probe, while this one only works with 50 ohm system. So you can connect this, right, with a 50 ohm coaxial cable connected to a RF current probe or a near field probe. So you can see this oscilloscope is really designed also for EMI and high-speed measurement. It just enables you the capability of seeing things in real-time time domain, okay, which we'll discuss later, okay. So, of course, being a receiver, the most important feature is the EMI analyzer. So let's have a look. If I click that, it brings me this interface, okay. So you can set up everything, and you can produce report, and have a look at the status and things like that. Okay, so let's have a quick walkthrough. First, of course, is the detector type. This you can see, you can select the CISPR detector type or military. Okay, so that's good, because obviously this receiver is designed for defense and military application, so military detectors are important. And here you can select different attenuation. So currently we have 20 dB, but if you select -30 dB, what it means really is it enables the preamplifier in the receiver. So yeah, you can have a much lower noise floor. Interesting is mode, okay? So if you select mode, you can have 5 different modes. Well, I use predominantly 2 modes. One is the pre-FFT sweep with selective peak measurement, because this mode gives me really fast measurement. But if I want to do a full compliance measurement and produce some nice report, I would select direct FFT full compliance measurement, okay? Just to show you how quick the FFT function is. So if I select this one, okay, now let's import some limits. Here, again, it gives you a library of different standards that you can choose. Of course, DO160, that's for aerospace application, military standard 461, and CISPR standard. Okay, so if I select the CISPR 25 conducted emission, class 5 voltage measurement just to demonstrate. Okay, so as you can see, quickly loaded are the peak, quasi-peak, and average limits. And if I just click this button, then you can see this is the speed we're talking about performing a sweep, right? And the function I'm using currently is pre-FFT sweep. Okay, now that's done. But of course, as I said, you can also do a direct FFT full compliance measurement. Okay, so that's on the receiver function side. Pretty simple to set up, as you can see. Okay, so I can quit this function. Being a receiver, of course, this one works as a spectrum analyzer. There's no surprise that. Click this, gives you the spectrum analyzer. It's worth mentioning that because this one works down to DC level, okay, it gives you many more functions because now you can see pretty much everything from 1 Hertz to 100 megahertz. Well, most of the spectrum analyzer or receivers in the market these days, they probably start something from 9 kilohertz or 1 kilohertz. Okay, so this one is really useful. Currently, you can see I selected from 1 hertz all the way to 100 megahertz, and I use 100 kilohertz as a resolution bandwidth. So if I click, then you can see it's basically performing some sweep. Okay, we're going to use this function later on just to demonstrate its capability, particularly in the lower frequency range. Okay, so that's very useful. Okay, so I can stop that, and yeah, again, you can select different detector type. For example, currently I have positive peak and average. Okay, and I have peak hold enabled. Okay, you can disconnect this, of course. Tracking generator function sets up here. You can easily figure it out by yourself. Okay, as I said, the unique selling point of this product is really its low frequency performance, right? And that is really useful for me, especially if I'm doing something related to power. If I want to analyze harmonics, for example, or build a filter for offline switching mode power supply, this is really useful. Okay, so stop that and quit. Good. Then another unique selling point is this oscilloscope. Okay, so click that, brings the oscilloscope software. Okay, so yeah, this is the oscilloscope function. It's worth mentioning that if you check the datasheet menu, you will see that on the vertex scale, you have 14-bit ADC. So that's again very cool because again most of the oscilloscope, especially the low-end oscilloscope, gives you only 10 bits, while this one gives you 14 bits. So you can potentially see a lot more information given the bandwidth. Okay, so bandwidth of course is limited to 110 megahertz in this case. Okay, so yeah, that's very cool function. Again, we're going to do a quick demo after that. Right, so we can quit. So yeah, apart from these three, you can also use the tracking analyzer. So this gives you the function, a tracking generator function. Okay, again, because it's working down to the DC level, you can use it for filter analysis, especially if you design a filter for offline switching mode power supply application. If you want to look at a very low frequency performance, extremely useful function, I would say. Okay, so yeah. Of course, it has some other functions here listed here, demodulator, but I don't normally use these functions. So yeah, really, this 4 lists this the unique selling point of this receiver. So let's do some very basic quick demo and just to show you the capability of this receiver. Yeah, so let's do a quick demonstration. You can see here I have a very small functional generator. Generates some signals and directly feeds into the RF input of the receiver. For this demonstration, we want to demonstrate the low frequency capability. Okay, therefore we start with 200 Hertz square wave with an amplitude of 200 millivolts peak to peak. Okay, so currently I'm feeding a square wave signals, and you can already see from the oscilloscope function, there is the waveform captured. Okay, let's do continuous sweep. Okay, yeah, so obviously you can change the scale horizontally and also vertically, just as your normal oscilloscope. Okay, all the details are showing here. Obviously, you can also capture the rise and fall time as you wish. You can change the sampling, of course, and the higher the sampling rates, of course, the more accurate it is. Okay, and yeah, so that's pretty cool. Wave, I can change to sine wave. Let's say, yeah, sine wave showing on the screen, pretty good. Wave, then do a ramp. Okay, yeah, here to the ramp, perfect. Yeah, well, this is a oscilloscope, as I said, so yeah, pretty cool. Yeah, I would like to do a higher frequency signal analysis using the oscilloscope function, but unfortunately, as you can see, my laptop is a very ancient laptop. Because the software does work quite well with the laptop itself. So if you have a higher spec, then you can do it much easier compared to me. Okay. Yeah, it's worth mentioning that remember that the vertical scale, it has a 14 bits ADC, so that gives you the sensitivity up to 1 microvolts per division. Okay, that's 1 microvolts per division, so that's pretty good. So you can just reduce it to 1 microvolts really, but I'm not gonna do this with this signal, right? So, but if you have a overshoot and ringing, that 1 microvolts per division is really, really useful. Okay. So, as I said, yeah, we can stop demonstrating here. Right. So now we feed in a square wave signal, as you can see here. Okay. And what we're going to do is we are going to do a FFT analysis of this and see what's happening. Okay. So I can stop that, of course. Yeah, and then I can quit. Okay, so this would quit the oscilloscope function, and then what I would do is I'm going to use the spectral analyze function. So currently, yeah, so spectral analyze function is enabled. Start again from 1 Hertz. And because this is a really, really low frequency signal I'm feeding, so I'm going to stop at 1 kilohertz just for this demonstration. Okay, 1 kilohertz. And you can see resolution bandwidth are set at 30 because it's a 200 hertz signals, right? Okay, so yeah, let's have a look. If I do continuous measurement, yeah, you can see now things start to update. This is my 200 hertz fundamental frequency clearly showing here. And then the next one is, this is 3, 4, 5, 6. Yeah, that's my third harmonics. You don't see any even harmonics simply because the duty cycle in this case I set as 50% duty cycle as shown previously on the time domain using oscilloscope function. Okay, so how about if I do a duty? Let's change from 50 to 60. Let's see what happens. Yeah, very quickly updated. Now I can start to see the second harmonics as well now, and of course the fourth harmonics. Yeah, this is pretty cool. Of course, it stops at 1K. I can do 10K, right? I can do 10K. Yeah, this is really, really cool. As I mentioned, most of the spectral analyzer in the market, they don't do well in the lower frequency range, but this one definitely can capture the signal and do the FFT very, very precisely and accurately. Okay, yeah, hopefully this demonstrates the low frequency spectrum function, which is the unique selling point of this product. Okay, so we're now changing to a 50 Hertz square waveform. Okay, just show you here. So again, we start with 1 Hertz, stop at 2K. Okay, currently I'm using 10 Hertz as the resolution bandwidth, and it shows me the fundamental frequency at 50, then third, fifth, and so on. Okay, I can of course reduce the resolution bandwidth, let's say 3. Okay, so as you can see, if I reduce the resolution bandwidth, of course I see things much clearer, but it does take a little bit longer because of course you change the filter setting of the resolution bandwidth. Okay, of course you can do even lower resolution bandwidth. It just takes longer, but you do have much better noise floor and see things a lot better. Okay, like this. Okay. Okay, next demo. We have a small filter board here. Okay, so it's a multi-stage filter that I built, CLC, LC, LC. Okay, connected to a 20 ohm path. Okay, and I'm using the tracking generator and RF input, and we're going to demonstrate how to and we are going to demonstrate the capability of the tracking analyzer function. Yeah, go to tracking analyzer, click that, brings the tracking analyzer windows. Okay, I can enable this graph so I can see it better. By default, 9K to 150K stop, points 401. So how about we do up to 30 megahertz? I wanted to really analyze this. Oh, sorry, 30M. Yeah, that will give me 30 megahertz tracking level 0 dBm, 100K resolution bandwidth. Yeah, let's start. Just have a look what it looks like. Click that. Currently it's linear. Okay, I want to look at logarithmic scale. Okay, and you can see scale per division is 10 dB, so maybe I want 20 dB. Okay, stop that, do it again, continuous beep. Take some time to perform the 401. Yeah, that's done. Okay, yeah, that's pretty good. You can see this gives me the insertion loss of this filter up to 30 megahertz as I set it up. Of course, I can extend into 100 meg. Okay, in this demo, we're going to test the speed of the receiver. So we got the timer here and here. Okay, so first we're going to start with pre-FFT sweep. Okay, so I'm going to press this button and start the timer. Let's do that. Okay, time starts. Okay, they're sweeping and still sweeping to 100 megahertz, 9 seconds. Okay, so it takes about 9 seconds to do a full sweep. Okay, CISPR 25, and this is pre-FFT sweep. Okay, so now let's check the so pre-FFT sweep give you two results, peak and average. Okay, so as I said, if you wanted to perform a direct FFT full compliance, then you do that. And we're going to do it again. Measurement start and start. So start. Okay, so this DUT start to sweep. As you can see, this is the direct FFT full compliance measurement. Okay, that's there. And you can see this gives you three results. So they are peak, quasi-peak, and average. Okay, three results using the CISPR detector. Okay, and so currently it's close to about 10 megahertz. Okay, time it uses about 38 seconds. So let's see how long it will take. And don't forget, as I mentioned, this gives you three results: peak, quasi-peak, and average. And we all know that quasi-peak often takes lots of time. So bear in mind that the result will also shows you this result with the quasi-peak result. So that's the beauty of this receiver. Okay, currently we are 2 minutes and a half past, and 80% is complete. So yeah, it's just gonna be a few seconds. 97, 100%. Yeah, about 2 minutes and 55 seconds. Let's say 3 minutes to perform a full compliance sweep. So if you enable this function, okay, which is enable selective peak measurements, and if you perform a pre-FFT, the results will basically measure automatically the quasi-peak and CISPR average for the spurious that exceed the limits. And this will also be super fast as well. However, you can imagine if there's a noise that has a big resonance hump that exceeds the limits in this whole region, then of course it will take long because you don't know how many points, thousands could be, that exceeds this limit. So yeah.
Good. Okay, so that's the end of this review. I hope you enjoyed it. I heard that the Tekbox will launch this product in May in the EMC and Compliance Conference in Newbury in the UK. So yeah, if you have a chance, pop in to see their stands. I think they exhibit with Telonic. So yeah, definitely have a go of this receiver and find out more information, more features yourself. Okay, enjoy.